I would like to remind you that you like this one, subscribe it and press the bell icon so that you can get the other videos which we are going to develop for the course of the differential equation. And moreover, as I told you before, that we are having the description. In the description, I have given my notes. In the notes, we are having more examples and more exercises. You can do the practice for that one. So the both things, don't forget it. So we just solve this example. We're having the equation of the differential equation is y double dash plus y equal to secant x. So this, due to secant x, this is not the equation we can solve with the help of undetermined coefficient. If it was sine x or cosine x, we are able to solve it. So for this one, we use the variation of parameter. The part 1 is same for both of them. Solution of this one, we take the homogeneous part of the differential equation to find yc, the homogeneous part of the solution. So we can write here y double dash plus y is equal to 0. Our substitution for this one is e to power mx. When substitute, we get the characteristic equations. Our characteristic equation for the y double dash plus y will be m square plus 1 equal to 0. We find the roots of this one. We get here m square is equal to minus 1 and m is equal to plus minus I. When we have m is equal to plus minus I, we compare it by standard complex number. The real part alpha is equal to 0 and beta, the complex part, is equal to 1. So in this case, we know that the equations we're having when y equal to e to power alpha x, c1 cosine beta x plus c2 sine beta x. My alpha is 0, my beta is 1, so I can write my yc, this is the homogeneous part of the solution. Alpha is 0 to e to power alpha is 1 and beta is 1. We get here c1 cosine x plus c2 sine x. Sometimes we change our sine and cosine, this doesn't make any difference. So this is, we get here the value of y1. So when we are going to apply this, this part 1 of my solution. Part 2, we want to find yp. To find yp, we're going to use the method that is variation of parameter. And for this one, we have yp is equal to u1 cosine x y1 plus u2 y2, that's equal to sine x. So now I can have my data. My data is, I have y1 is equal to cosine x, my y2 is equal to sine x. To write my u1 dash and u2 dash, I need y1, y2, f of x. I have my f of x. For f of x, this coefficient must be 1. So my f of x is equal to secant x. So this is my, what's left? Left is to find w, the Wronskian. So I find my Wronskian, my w is equal to y1 is cosine x and y2 is sine x. y1 dash is minus sine x and y2 dash is cosine x. Find the, calculate this determinant. Cosine x into cosine x is cosine square x. We are having here multiply with a plus sign, and we take this determinant multiply by the negative sign, minus minus become plus, and sine square x. So you know the value of the determinant of function, the identity, cosine square x plus sine square x is equal to 1. So this is equal to 1, and we have the condition that this must not be equal to 0 in the Wronskian, because we are using here in the denominator. When this is 0, then there is no solution. So we say this is not equal to 0. So it's not equal to 0, it's equal to 1. It's mean we have the data. Now I can write here my u1 dash. My u1 dash is minus. As I told you, is 1. We're having here y2 f of x over w. So we can write here is minus. Alright, first y2 is our sine x. Sine x into f of x. f of x is secant x over w, that's equal to 1. So we can use this one and just clean the board so that we can use the space for writing the solution of our problem. So we are having the secant x, we know secant x is 1 upon cosine x. So we can write this is equal to minus sine x into 1 over cosine x, and this is equal to minus tangent x. So that's my u1 dash. My u2 dash is equal to here u2, we get here y1 f of x, and you know how we get here from the determinant we get y2 f of x and y1 f of x over w. What's my y1? y1 is cosine x into secant x over 1, and we having here cosine x into 1 upon cosine x, secant x is 1 upon cosine x, is equal to 1. So we want to find, we have u1 dash and u2 dash, we can find the value of u1. But the value of u1 is integration of this one. This is minus integral of tangent x dx. Here you must know the formula for tangent x. The integral of tangent x dx is equal to ln of secant x. And if we're having here minus tangent x dx, we have the property of ln, we can use that one. We get here ln of cosine x. So we are having here ln of cosine x. So I can write here, this is my ln of, I put here absolute value cosine x because ln we take always of the positive values. The u and u2 dash we integrate that one, that is equal to dx. We do that is 1, and what's the value? We get here x. So I can write my y2 yp. What's my yp? My yp is u1. Here is my yp, u1 cosine x plus u2 sine x. u1 cosine x plus u2 sine x. We have the value of u1. u1 is ln of x. So I get here ln of, so value of cosine x into cosine x. So that's my u2. My u2 is x, so plus x sine x. I have my y2, yp, I have yc. I can write my general solution. My general solution of the problem is the combination, linear combination, superposition of the solution, yc plus yp. We're having y is equal to yc. Yc is c1 cosine x plus c2 sine x plus yp. Yp, I write the cosine first. I have cosine x into ln of cosine x, and then I having a plus x sine x, and that's my solution of the problem. So again, as my habit, I try to revise the solution all the times. This is my differential equation, and for this differential equation we are going to use the method, the variation of parameter, because of the secant always is same. First find the homogeneous part of the solution. We take homogeneous part of the differential equation. This is our substitution. For that one, substituting, we get the characteristic equation m square plus 1. We're having here m square plus a square equal to 0. The roots will be m is equal to plus minus a. When m square minus a square equal to 0, then m will be equal to here ai. Here will be plus minus a. So that's the difference. Here plus sign, because when we take to the other side we get minus and write iota square. So here we get minus 1, we get plus minus iota square. Then we are having the real part is 0, imaginary part is 1. We get e to power 0x is equal to 1, and we get here c1 cosine x, beta is 1, c2 sine x, beta is 1. Then we write here the second part of our solution. To find yp, we use variation of parameter. This method we are using. For this method, we write the yp as u1 cosine x plus u2 sine x. We have the value of, we have to find the value of u1 and u2. For that one, we have already derived this formula that u1 dash is equal to minus y2 f of x. This is the value of the determinant. W is equal to u2 dash is y1 f of x over w. We need y1, y2 f of x. We have y1, we have y2, we are having here f of x. This is my f of x. Now I want to find w. That's the Wronskian. We have y1, y1, y2, y1 dash, y2 dash. We solve it. We get here 1. This is not equal to 0. We can solve it with the help of the Cramer rule. So in the Cramer rule, we are having here u1 dash is w1 over w, u2 dash is w2 over w. We get here u1 dash, that's equal to minus tangent x, u2 dash, that's equal to 1. We integrate both the sides, minus tangent x, as we've seen here. Integral of tangent x is ln of secant x, and minus tangent x is ln of cosine x. So we get here this ln of cosine x, and derivative of integral of u2 dash, this 1, here we get dx, integrating both the sides, we get here x. We put the value of u1 and we put the value of u2, and then we put the value of yp here, combining the combination of yc and yp, that give me the solution.